Okay, good. All right, so what I have opened up is the prototype drawing for Capstone 1. And when you open it up, you're going to see the 3 rectangles, but the miter box layer is going to be off. So what's going to happen when you open this up is you're going to see these 3 rectangles here. In your isometric drawing, the assembly is going to go here, and the details for the toe stop base and the cleat pin are going to go here. And then in this 3rd rectangle over here, that's where the cleat will go, and then also where you're going to put notations for the hex cap screw, hex cap nut, and the washer. And so one of the first things you would want to do if you're doing Capstone 1 would be to come in here to your layers and turn on the miter box layer, and so that you can see it, because you're going to draw your views inside this miter box here for details 1, and inside this miter box over here for details 2. So now to show you what that looks like, I'm going to turn on the views, and I made a layer called multi-views for demo. I'm going to turn that on. So what you'll see is that in the lower right hand corner, that's where you're going to start your front view. And then in the lower right hand side over here, you'll be drawing your your right side view, and then your top view will go right up here, but we're going to do the top view as a full section. So when you look in Blackboard, there is a PDF help sheet for doing this. It's called, it has the word miter in it, and so it's the help sheet for drawing the multi-views, and it says miter help sheet. That's the one you'll want to look at, that will help you with creating these views, and also creating these views over here of the cleat. And like I was saying the other day, on the cleat, we're going to do something a little different. We're going to draw our front view in the upper right corner, and then our bottom view is actually going to be in the bottom right corner, and then we're going to draw a left side view on the left upper corner over here. And so one of the things I was getting at a second ago was then things like the hex cap screw, the hex nut, and the washer are just going to be notated. And so there's a format for that. And actually in the prototype, you're going to see this note right here. And that note you can copy over to here and copy it several times and just make edits to that. And so this hex cap screw note, I wanted to show you something about it. It tells you what the size of the hex cap screw is. And the hex cap screw has screw threads on it. And the screw thread is this part of that note right there where it says 0.75-10 UNC-2A by, that's the X is in this case used to say by, 5.0 inches long. So the 0.75 is the diameter of the screw thread. So this is 3/4 inch screw thread. The 10 refers to the number of threads per inch. So it's 0.75 in diameter. There are 10 threads per inch. There are different types of screw thread, and UNC screw thread stands for Unified National Coarse. So this is coarse screw thread. And then we finish that off with this 2A. And what 2 indicates is what's called the class of fit. And the class of fit in a class 2 fit is sort of like your hardware store variety. A class 3 fit is a tighter fit and more expensive to make. And so generally you don't specify that unless you really need that. A tells us that all this thread note right here is for external thread, which makes sense on a screw because the screw has external thread on it. But the hex nut that would fit onto this screw has the same thread note, except it finishes in a B, 2B over here instead of 2A. So those are the differences in this one. And then it even says, 1 required, because there's only 1 required for the assembly. On the washer, though, we have some numbers here, and it says diameter 0.812. And what that refers to as the inside diameter of the washer. And then we have a diameter 1.75. That's the outside diameter of the washer. And the 0.148 is the thickness of the washer, and there are two required. So instead of drawing these, all you'll need to do is put the notations on there that accompany the drawings. And so, like I was saying, over here when you draw your isometric assembly, in order to draw some of those things like the angle for your counter sunk hole and stuff like that, you actually need to have the 2D view drawn of the countersunk hole. So you're going to have a couple of opportunities to draw the countersink right over here. And but here's the thing: once you've drawn the countersunk hole once, you could copy it over to the side and rotate it and just move it in over here where we see the countersunk hole right through there. Now, what you're seeing in this side view right here is where this hole, the smaller hole that we see right here, where that hole that goes all the way through intersects this hole that's going through in this direction. And what we wind up with where those two holes intersect is called a saddle. So we actually have a video in Blackboard for how to draw these two saddles that you have in this view. Okay, so you will get some help with that by watching the video over there. So what I'm going to do now is just go to the check print for this, and I'm going to go back into model space. And so this is what the isometric drawing looks like when it's done. And as I was saying, you'll draw it second. Now, the way you determine how far down this ellipse is from the center of this ellipse right here is this. The distance from the top plane right here to where this ellipse is located, this one right down here, you find by going over here to your view and measuring the distance from here to where the countersink hits. Might be better to show you that in the top view right here. The distance from this plane to that surface right there, that's the distance that you need to find out so that you can copy that into the isometric view. Now, a good way to do that distance would be to type DI. DI is the shortcut for distance, and then just press enter. And then you'll snap at that intersection and snap at that intersection. And then off to the side, it will tell you what the distance is when you do that. So the DI command is really powerful for doing things like that, finding distances that you need. Okay, let's see. The cleat pin, we're just going to kind of fit it right up here. One thing I want to point out about the cleat pin is that it has these chamfered edges on it. And this edge over here has a chamfer on it. And the chamfer is 0.06 by 45 degrees. And so the 0.06 is the distance from like this corner to that corner right there. But when you set up for your chamfer command, remember it's behind the fillet command. So if you go to fillet and you pick on the down arrow and you pick on chamfer, and you look down here on the command line, let me get this out of the way. Look down here on the command line. When you know a distance and an angle, what you can do, you can pick on this and it will say, what's the chamfer length? And you would type 0.06 and enter. And then it's going to specify the chamfer angle and you type 45 and enter. And then you would just come in here and you would pick this line and you would pick this line. So I'm just going to pick two lines like that just to show you how it would chamfer that off. So like I said, the way you do that is just pick on chamfer and either pick on angle or distance. I'd probably pick angle first. And this is what's weird. You pick on angle, but instead of asking for the angle first, it asks you for the chamfer length, which would be the 0.06. So instead of putting a dimension on all those chamfers, I just put a note that said, unless otherwise specified. That's what UOS stands for, unless otherwise specified. And that abbreviation right there is approved by ASME, you know, the guys who make the rules. Unless otherwise specified, chamfers are 0.06 by 45 degrees. All right. So those are a few things, but you guys can always contact me if you have questions and ask me, what's going on. And so that's the first one.